Hello, I'm Ansar Gül, CEO of Turksat. We have been waiting for this moment for last 16 months. Now everything is ready and our 4B satellite will be launched this evening. So with 4B satellite, we are going to provide data services from Afghanistan to Europe and including Middle East and of course Turkey. This is a good cooperation between Melco, Japan, ILS, United States, and of course Proton, Russia, and Turkey. This is a good moment for us and for all of these countries. I hope the launch will be successful and we will get our satellite operational in a very short time. Thank you.
Hello, I'm Kirk Peischer, the president of ILS. It's my pleasure to be greeting you in front of the Proton Launch Complex here at the Baikonur Cosmodrome, alongside the colleagues of Melco and Turksat. Today we will be launching the second of our Turksat satellites, Turksat 4A, which we launched last winter, and now Turksat 4B. Turksat 4B is a satellite which will be providing broadcast services through a large geographic portion of the world. I'd like to take this opportunity to thank all the teams that worked very hard to get us to this point. The teams that here at Baikonur working the mission, as well as the teams back at all our home bases. Thank you very much, and I'd like to again thank our customer, Melco and Turksat, for putting their trust in ILS, Krunichev, and the Proton launch vehicle.
You're looking live at the ILS Proton launch vehicle on Launch Pad 39 at the Baikonur Cosmodrome in Kazakhstan, with the Turksat 4B satellite on board. This is the second ILS Proton launch for Turksat, and it's a collaborative effort between ILS, International Launch Services, Krunichev State Research and Production Space Center, Turksat, and satellite manufacturer Mitsubishi Electric Corporation. Liftoff is scheduled for October 16th at 4:40 p.m. here in Washington, D.C. at the ILS Broadcast Center, October 16th at 11:40 p.m. in Ankara, Turkey, October 17th at 2:40 a.m. in Baikonur, Kazakhstan, and October 17th at 5:40 a.m. in Tokyo, Japan. Thank you for joining us. The countdown to the launch of Turksat 4B begins now. Hello and welcome to today's coverage of the launch of Turksat 4B aboard an ILS Proton. I'm Karen Monahan, Director of Communications for ILS. With me once again is my colleague John Palme, Vice President of Programs and Operations for ILS. And John has worked on over a dozen launch campaigns in Baikonur and has co-hosted many of our live shows. Thanks again for joining us, John.
Hi, Karen. As always, it's great to be here with you. So let's get started with just a few details about today's launch. This will be the 91st ILS Proton launch and the 407th Proton launch overall since Proton's first flight in 1965. This will be the fourth ILS Proton launch of 2015. The satellite operator for today's launch is Turksat, headquartered in Ankara, Turkey. And this will be the second Turksat satellite launched aboard an ILS Proton. Turksat 4A was launched successfully in February of 2014. The satellite manufacturer is Melco, or Mitsubishi Electric Corporation, which is headquartered in Tokyo, Japan. This will be the second Melco satellite launch on an ILS Proton.
And now we have a video produced by Turksat focusing on their current and future technology and services, narrated in Turkish. Let's take a look.
bilginin göz açıp kapayana dek binlerce kilometre kat ettiği, beklentilerimizin hızla değiştiği, teknolojinin yeni deneyimlere açıldığı bir çağ. Yaşadığımız çağ, iletişim çağı. Yaşantımızı anlamlı kılan, insana dokunan değerlerle bilginin aydınlattığı yolda ilerliyoruz. Yenilikçi teknolojinin peşinde geleceğin TürkSat'ını birlikte yükseltiyoruz. TürkSat, yeni deneyimlerin peşinde öncü ve hızlı bir şirket. Geleceğin bilgisine yatırım yapan, titiz, uzman ve güven dolu bir kadro. Dünya ile iletişimin kapılarını açan ve esinleyen bir değerler bütünü. TürkSat, bilişimde, kablo yayıncılığında, uydu teknolojilerinde, bölgesinde lider, dünyada önde gelen bir şirket.
Service 3 Foxtrot Hotel, contact 128.8
%92 doluluk oranıyla yüzlerce televizyon ve radyo kanalını evlerimize ulaştıran, kamu kurumlarının ve özel şirketlerin her türlü haberleşme ihtiyacını karşılayan TürkSat 2A ve TürkSat 3A, kapsama alanımızı Sahra Altı Afrika'ya kadar genişleten TürkSat 4A ve mobil internet hizmetlerimizi çok daha ekonomik bir şekilde sunan TürkSat 4B, 2016'da TürkSat 5A, 2017'de uzaya gönderilecek olan ilk milli haberleşme uydumuz TürkSat 6A, yine Türkiye'de üretilecek olan TürkSat 7A ve TürkSat 7B haberleşme uydularıyla 2020'ye dek dünya karalarının %71'ine, dünya nüfusunun %91'ine uydular üzerinden hizmet sunan bir TürkSat. Bugün bilişim sektöründe faaliyet gösteren, onlarca projeye imza atan TürkSat'ın işlettiği E-Devlet kapısında yaklaşık 17 milyon kayıtlı kullanıcıya, 100'ün üzerinde kamu kurumuna ait 1000'e yakın kamu hizmeti sunuluyor. Kullanıcı sayısının 2'ye katlanacağı geleceğin TürkSat'ında E-Devlet kapısı üzerinde binlerce kamu hizmeti yer alacak. Kablo yayıncılığı alanında faaliyet gösteren TürkSat, TürkSat kablo platformu üzerinden Tele Dünya markasıyla dijital TV yayın hizmeti ve Uydunet markasıyla geniş bant internet erişim hizmeti veriyor. Dijital TV hizmetlerini yaygınlaştırmayı, zenginleştirmeyi ve analog yayından dijital yayına geçişte IP tabanlı yeni teknolojileri müşterilerimizle buluşturmayı hedefliyor. TürkSat, uydu haberleşmesinin yükselen değerleriyle teknolojilerine yöneliyor. Daha mobil, daha çeşitli, performans açısından daha verimli ve daha ekonomik çözümlerle birlikte uzay ve iletişimin kesişeceği alanlarda iletişimin, yayıncılığın, bilişimin ve coğrafi bilgi teknolojilerinin yükselen ve güvenilir değeri olmayı hedefliyor. Geçmiş, şimdi ve gelecek. Hepsi bir anda buluşuyor. Büyük düşünceleri, büyük atılımları esinleyen bir an. Geleceğin TürkSat'ı sizi bu ana çağırıyor. TürkSat, iletişimde uzay çağı.
We're now about 17 minutes from launch. And John, can you give us an update on the current weather conditions in Baikonur?
Sure, Karen. The most recent weather readings I've received show that they currently are under cloudy skies with about 10 kilometers of visibility. Predictive liftoff temperatures of 4 to 6 degrees centigrade or 39 to 43 degrees Fahrenheit. Ground winds are out of the northwest at around 4 to 7 meters per second, which is well within limits. And the upper level winds, they're within limits as well at all altitudes. So the weather is well within our constraints, and we're currently go for launch. The ILS Proton mission for the Turksat 4B satellite will entail 5 Breeze M burns and take 9 hours and 13 minutes from liftoff to injection into geostationary transfer orbit. Now, let's take a look at the Turksat 4B mission profile. The following animation depicts the Geosynchronous Transfer Orbit, or GTO, mission flight profile of the ILS Proton launch vehicle with the Turksat 4B communication satellite on board. The function of Proton's first 3 stages is to propel the orbital unit to a suborbital trajectory. The Breeze M payload adapter system and the Turksat 4B satellite comprise the orbital unit. The ignition of the powerful first stage engine starts the sequence, outputting 2.4 million pounds of thrust at sea level. Then, the ILS Proton lifts off from its launch pad and immediately executes a roll maneuver to align its pitch axis with the flight launch azimuth of 61.3 degrees. This allows the vehicle to achieve a parking orbit inclination of 51.5 degrees as it travels in an east-northeast direction across Kazakhstan towards the Pacific Ocean. For about 2 minutes, the first stage engines fire, during which time the ILS Proton experiences maximum dynamic pressure. Then, the first stage separation from the second stage occurs. The second stage engines ignite with nearly 540,000 pounds of thrust for 3.5 minutes, followed by the third stage engine with 131,000 pounds of thrust for another 4 minutes. The payload fairing is separated soon after third stage ignition, high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia, near the eastern edge of Kazakhstan at 51.5 degrees north latitude, and is now moving about 7,300 meters per second, or 4.5 miles per second relative velocity. The Breeze M is the upper stage of the rocket and is designed to inject payloads into a wide variety of target orbits. There are 5 Breeze M burns in this GTO mission design. The first Breeze M burn occurs about 2 minutes after the third stage separation, when the orbital unit is still in a suborbital trajectory. This will last long enough to achieve a low Earth circular parking orbit of 173 kilometers. This 4.5-minute burn spans from Siberia to Russia's east coast. After 1 orbital revolution, the second Breeze M burn for the Turksat 4B mission occurs. This is about 52 minutes after the first burn main engine cutoff, or MECO. The resulting elliptical orbit is called the intermediate orbit and increases apogee to 5,000 kilometers, perigee to 270 kilometers, and decreases inclination to 50.3 degrees. This 17.7-minute burn spans from the South Atlantic, 800 miles east of Rio de Janeiro, to Libya. 2 hours, 3 minutes after second burn completion, the third Breeze M burn starts. After this burn completes, the depleted auxiliary propellant tank, or APT, is jettisoned, and the fourth Breeze M burn begins. The resulting orbit is called the transfer orbit, where the apogee is greatly increased to 35,799 kilometers, closely matching the geosynchronous altitude, making the orbit more elliptical and maintaining the equatorial plane perigee location. The combined burns add up to approximately 20 minutes in duration and span from the South Pacific 200 miles west of Santiago, Chile, to 300 miles west of Morocco. During the coast phases between main engine burns, the Breeze M performs various attitude maneuvers in order for the Turksat 4B satellite to be exposed to the sun at predetermined solar illumination angles, designed to satisfy its thermal and power requirements. Approximately 5 hours later, during the 5th and final Breeze M burn, the orbital unit will perform a large plane change maneuver from 49.1 degrees to 13.3 degrees of inclination, increases its apogee to 35,786 kilometers, and increases perigee to 9,141 kilometers in an 8-minute, 57-second burn. About 12.5 minutes after MECO, the Turksat 4B satellite is separated from the Breeze M to reach its final GTO target orbit. The total mission time from launch to Turksat 4B spacecraft separation is approximately 9 hours and 13 minutes. Once Turksat 4B completes its in-orbit testing, it will provide telecommunication and DirecTV broadcasting services over a wide geographic region between the eastern edge of England and the western edge of China, which spans Turkey as well as Europe, Central Asia, the Middle East, and Africa. Turksat 4B will operate in its orbital slot at 50 degrees east longitude.
The first burn of the Breeze M upper stage is scheduled for completion about 16 minutes into the flight. Our broadcast will conclude at that time, since the upper stage with the Turksat 4B satellite on board will be in a planned blackout period when it will be out of range of the ground tracking stations. At that time, we won't receive any updates until it comes back into view about an hour later. You can stay up to date on the key milestone missions by visiting the ILS website, ilslaunch.com, by following us on Twitter, and by liking us on Facebook. Melco Senior Vice President and Group President for the Electronic Systems Group, Mr. Yoshiaki Nakatani, joins us now with the greeting recorded earlier in Baikonur.
My name is Yoshiaki Nakatani. I'm Senior Vice President of Mitsubishi Electric Corporation and Group President of the Electronic Systems Group. Turksat 4B is our second communication satellite for Republic of Turkey. Following Turksat 4A launched last year, we are very happy that we have finally reached the moment when Turksat 4B will be launched. I feel these two satellites are the symbol of cooperation between Turkey and Japan, as well as between our customer Turksat and us, Mitsubishi Electric. We are very proud of contributing to Turkish communication infrastructure by our qualified and reliable space technology with them, and also would be for the future ones. I believe Turksat 4B will be launched successfully shortly. And after that, we will make it ready for the customer to provide high-quality services at the earliest possible moment. I appreciate very much the support from our customer Turksat, the launch provider ILS, and all the people involved in this project. Thank you very much.
The Proton launch vehicle can weigh over 1.5 million pounds at launch and is 191 feet tall. But just exactly how fast can it go? Here's a speed comparison that will help put it into perspective. Velocity is the distance per unit time that an object travels in a specified direction. We all know the ILS Proton moves at incredible speeds. That's a given. But just how fast is a Proton rocket exactly? At liftoff plus 38 seconds, here's the formula for the answer. 567 miles per hour equals 253 meters per second. Using this formula, the Proton closely matches the velocity of several of the world's fastest commercial jetliners at cruising speed. At liftoff plus 68 seconds, here's how fast the ILS Proton is moving. Mach 2, or twice the speed of sound. At this point in the mission, the Proton matches the velocity of an F-22 Raptor with full afterburners engaged. Finally, at liftoff plus 82 seconds, the ILS Proton is traveling at Mach 3, or 3 times the speed of sound. At this point in the mission, the Proton matches the velocity of an SR-71 Blackbird U.S. reconnaissance jet. We'll leave you with this staggering thought about the velocity of an ILS Proton rocket. At maximum velocity, the Proton travels at 5.9 miles per second. At that velocity, the Proton can travel from San Francisco, California, on the United States West Coast, to New York, New York, on the United States East Coast, in 7.3 minutes. All right, we're about 8 minutes away from launch. And here's a message from Mr. Masamitsu Okamura, Melco Group Senior Vice President and General Manager of Kamakura Works.
I'm Masamitsu Okamura, General Manager of Kamakura Works Mitsubishi Electric Corporation. We, Mitsubishi Electric, have conducted the design and manufacturing of two satellites, Turksat 4A and 4B, with the highest priority. It was a very impressive project for us because of our first satellite project for Turkey. In addition, the Turkish young engineers were participating in manufacturing and testing for the satellites. For the launch of Turksat 4B today, I'm confident that the satellite would be ready to work with perfect quality and performance by our technology and workmanship after successful launch, as well as Turksat 4A. I would express our sincerely appreciation for the Turksat great support that enabled us to do this. And also I would appreciate the ILS excellent cooperation in delivering the satellite to the customers. Thank you very much.
Now here's a video about Turksat 4B, prepared specially for this launch by Melco. Now a greeting from Mr. Yasunori Komochi, Melco Group Vice President and General Manager, Space Systems Division.
Good morning, ladies and gentlemen. I am Yasunori Komochi of Mitsubishi Electric Corporation. Turksat 4B is our 9th satellite of Mitsubishi standard platform DS2000 and second satellite for Turkey. On 6 days after launch, the satellite will reach the geosynchronous orbit at 50 degrees east, and then will be handed over to our customer Turksat after conducting in-orbit test. This satellite has various payloads, a Ku band, K-band B, K-band multi-beam, and C-band. I believe this satellite will make a great contribution to the business expansion of our customer Turksat with high reliable payload. I am very delighted to be at this exciting moment with our customer and Turkish people. We are looking forward to see successful launch to be conducted shortly. I will watch it with sincere thanks to all. Thank you very much.
And now John's going to take us through the final pre-launch preparations and through liftoff of Turksat 4B. John?
Thanks, Karen. We're getting pretty close to launch time. The latest weather readings indicate we're still within the wide Proton design envelope for launch. Preparation for today's mission started about 3 years ago with the building of the satellite and the mission integration and planning of this launch on this ILS Proton. Mission teams are in their places in the launch bunker, control rooms, ground stations, and communication centers around the world, and the final go for launch polling has been completed. In addition to those at the Baikonur Cosmodrome, there are many others who have played an important part in the Turksat 4B mission. We'd like to say thanks for all your hard work in getting to this moment. This includes Turkish Ministry of Transportation, dedicated employees of Turksat in Ankara, Turkey, the hard-working professionals of Mitsubishi Electric Corporation in Tokyo, Japan, Khrunichev employees in Moscow and other regions of Russia, ILS headquarters in Reston, Virginia, and many, many others who have helped make today's launch of Turksat 4B a reality. We're coming up on 30 seconds before launch. It's a very clear shot of the rocket, but there is a cloud deck today, so we expect the rocket to disappear into that pretty soon after launch. Coming up on T-minus 15. And now I'll step aside as we watch the launch of Turksat 4B. And we have ignition. And we have liftoff of an ILS Proton from the Baikonur Cosmodrome in Kazakhstan with the Turksat 4B satellite on board. Now, about 10 seconds after liftoff, the vehicle does do a roll maneuver to align the launch vehicle pitch axis with the northeasterly launch azimuth. Unfortunately, with the cloud deck there, the vehicle is now out of sight of the cameras, but the vehicle will soon experience maximum dynamic pressure, or max Q. Now, this is when the aerodynamic stresses on the vehicle in atmospheric flight are at their peak. And for Proton, max Q occurs about 1 minute and 2 seconds after liftoff and at a velocity of Mach 1.6. And it's sometimes accompanied by visible condensation if atmospheric and lighting conditions are favorable, which unfortunately today they're not. From the information I'm receiving, everything seems to be proceeding nominally as the vehicle ascends over the Cosmodrome in a northeasterly direction with a flight launch azimuth of approximately 61.3 degrees. We're about 90 seconds after liftoff. And we're coming up on the first stage separation from the second stage. Now that's set to occur at 2 minutes into the flight. And on clear nights, unlike tonight, observers in the Baikonur Cosmodrome may be able to see a bit of a halo effect of light as the second stage engines ignite prior to the separation from the first stage. Coming up in 1 minute and 50 seconds after launch. First stage shutdown should occur in about 15 seconds. Okay. And I'm waiting for confirmation of the ignition of the second stage and a good separation from the first stage. Unfortunately, we can't see it today, so we're waiting for the data to be relayed back to the comm center. Okay, and I do have confirmation of a good ignition of the second stage and a good separation from the first stage. And we have confirmation of the planned level of thrust on all 4 second stage engines. Now the second stage will operate for about 3 minutes and 27 seconds. The next key mission milestone will be the separation of third stage from the second stage at L plus 5 minutes and 27 seconds. 20 seconds after that, the payload pairing pyros will fire, which will separate the two halves and jettison them from the vehicle. Lastly, as the ILS Proton travels northeasterly downrange from Kazakhstan into Russian territory, our viewers may notice some brief planned time lags in our reporting of key mission milestones, as the telemetry has to be relayed from multiple ground stations.
The first burn of the BRIESM upper stage is scheduled for completion about 16 minutes into the flight. We'll conclude our live coverage after that burn, since the rocket will be out of range of our tracking stations. Now let's take a chronological look at Turksat 4B's journey to launch.
Commercial satellites that launch aboard the ILS Proton take approximately 2 years to manufacture, test, and ship to the launch site in Baikonur. The launch campaign begins with the arrivals of the spacecraft and the crew in Baikonur. At Yubileyny Airfield, the spacecraft arrives aboard a massive Antonov cargo jet. The spacecraft is then carefully offloaded to a rail car from the cargo bay of the Antonov. The spacecraft then makes the 6-hour rail trip to the launch processing facility. The rail cars that transport spacecraft are thermally controlled to maintain proper environmental conditions. In the high bay, systems tests and other operations, including fueling the spacecraft, are performed by the crew. Joint operations now begin to bring all the flight hardware together. In Hall 101, the satellite becomes mated to the Breeze-M upper stage and then rotated horizontally to be encapsulated within the payload fairing. Each mating activity is accompanied by joint testing to verify everything is functioning properly. The spacecraft, fairing, and upper stage are referred to as the ascent unit from this point forward. In Hall 111, the booster stages are mated to form the entire assembly of the ILS Proton integrated launch vehicle. The integrated launch vehicle rolls to the Breeze-M fueling station, where fueling of the Breeze-M is completed. The complete rocket rolls out to the launch pad. Here, hydraulic erectors move the rocket from a horizontal to a vertical position. Then the mobile service tower moves in to provide services and accessibility to the launch vehicle and spacecraft. The precise time the vehicle for Yuri Gagarin rolled out in 1961, 6:30 a.m., is when each Proton is rolled out to the launch pad, marking this landmark anniversary in space achievement.
The Proton rocket is able to lift very heavy payloads into orbit. Proton launched Russian interplanetary missions to the Moon, Venus, Mars, and Halley's Comet. Proton also launched the Salyut space stations, the Mir core segment, and both the Zarya and Zvezda modules for today's International Space Station. Proton is a powerful rocket with the first stage engines producing 2.4 million pounds of thrust at sea level. Let's take a moment to learn more about the development of Proton. The Proton is a heritage launch vehicle with a long and significant history in space. Here are some quick facts. The Proton is the largest and most powerful Russian launch vehicle in operation. Proton has launched more than 400 times since the mid-1960s. Khrushchev State Research and Production Space Center, the majority owner of ILS, is one of the pillars of the global aerospace industry and manufactures both the Proton rocket and the Breeze-M upper stage. While the first Proton mission was in July of 1965, the first commercial ILS Proton launch took over 30 years later, in April of 1996, with the Astra 1F satellite for SES. The UR-500 vehicle's first 3 payloads were spacecraft called Proton 1, 2, and 3, and subsequently the launcher was named after its original payload. Khrushchev manages federal launch missions, while ILS offers the Proton for commercial satellite launches. We're just now 7 minutes into flight and coming up on some important milestones. So John, what can you confirm for us?
So since our last update, I can confirm that we have good stage 2-3 separations, stage 3 startup, and jettison of the payload fairing. Now, payload fairing jettison occurs at a velocity of about 4,600 meters per second, or 2.9 miles per second, at an altitude of 137 kilometers. Our next major milestone happens in about 4 minutes, and that will be separation of the Proton's 3rd stage from the Breeze-M upper stage.
The Turksat 4B mission team for this ILS Proton launch is made up of representatives from ILS, Turksat, Khrushchev State Research and Production Space Center, and Melco. Here's the first in a series of messages from the Turksat 4B mission team from Russ Prytula, ILS Program Director for the Turksat 4B launch.
Well, we are back. We launched Turksat 4A in February of 2014, and now the teams have returned to the Baikonur Cosmodrome to launch the second Melco spacecraft, Turksat 4B. I'm Russ Prytula, ILS Program Director for the Turksat 4A and 4B missions. While the 4A campaign was held in frigid winter conditions, We have enjoyed fantastic fall weather for 4B. 4A was a Pathfinder campaign for the first Melco spacecraft on Proton, and we learned many valuable lessons that we could apply to 4B. The result, despite a few unforeseen challenges, was a relatively smooth operation over the last several weeks. We're coming off the recent successful flights of Inmarsat 5F3 and Express AM8, and now it's our turn. We've really enjoyed working with the competent Melco and Turksat teams. Now that they are seasoned Baikonur veterans, we would certainly welcome the opportunity for yet another mission. Many thanks to Melco, Turksat, Krunichev, and all the teams that have worked so hard to make this launch possible. As always, go Proton, go BRIESM, go Turksat 4B.
The launch site for Proton missions is the Baikonur Cosmodrome. Let's take a closer look at the launch facility. The Baikonur Cosmodrome is the world's first and largest operational space launch facility and has been in operation since 1955. It's located in the desert steppe of Kazakhstan, approximately 2,100 kilometers or 1,300 miles southeast of Moscow. The Cosmodrome is a large complex that extends about 100 miles from east to west and 55 miles north to south, which is about the size of Holland. Under Roscosmos, the Russian Federal Space Agency, Baikonur remains a busy spaceport with numerous commercial, military, and scientific missions being launched annually. The Baikonur Cosmodrome is under a long-term lease from the Republic of Kazakhstan. Today's ILS Proton will launch from Pad 39 in Area 200, one of the 3 launch pads available for Proton launch use. So John, what is the current status?
So since we last spoke, the third stage completed its work, has successfully separated from the orbital unit, which is comprised of the BRIESM and the spacecraft. And currently we're waiting for the first of 5 BRIESM burns to start on time in a couple minutes here.
Great, thanks. The BRIESM upper stage is a restartable upper stage for mission optimization, is compatible with all major commercial spacecraft platforms for dedicated single and multiple launches. The BRIESM can support dual-use satellites and satellites with hosted payloads and has demonstrated the capability to build and serve space stations. Let's learn more about Proton's technology and its role in the Turksat 4B mission now.
Soon we will have stage 3 separation from the BRIESM. The orbital unit, or the spacecraft together with the adapter, separation system, and BRIESM, will be traveling at approximately 7,300 meters per second at the moment of separation, or more than 16,000 miles per hour. The BRIESM will ignite for its first burn about 1.5 minutes later and will last about 4.5 minutes. About 4 minutes after the first main engine cutoff, or MECO 1, the vehicle is scheduled to go out of range of our ground tracking stations. After about 70 minutes, we will reacquire the signal prior to the second burn of the BRIESM.
Now let's hear a translated interview with Mikhail Yakimchikov, Krunichev Program Director, about today's Turksat 4B mission.
Dear colleagues, friends, Turksat 4B spacecraft launch campaign is nearing completion. For Krunichev and ILS, that will be a second launch of the spacecraft manufactured for Turkey by Melco from Japan. For almost 3 years we have been efficiently working together in a friendly atmosphere. Hopefully, the results of this activity will not be lost, and in the near future we will see new spacecraft made by Melco to be launched on Proton. I think, and I'm sure, that Melco and Turksat specialists will return to Baikonur. I would like to express thanks to our colleagues from Melco, Turksat, ILS, RUAG, and certainly to all of Russian specialists for their high professionalism and trust in Proton. Now we are looking at Proton with Turksat 4B spacecraft on the launch pad with faith, hope, and love. Thank you.
We're continuing to track the flight of Turksat 4B into orbit on ILS Proton, and we're going to look to John now for another update on the mission.
So at this point in the mission, the first of the 5 BRIESM burns should have started. We're currently waiting for confirmation of that from our friends in Baikonur, and I'll let you know as soon as we hear that.
In the meantime, representing satellite operator Turksat is Program Manager Taha Tetik.
Hello everyone. from Baikonur Cosmodrome Launch Base. I am Taha Tetik, Program Manager of Turksat 4A and Turksat 4B satellites for Turksat. We have been waiting this launch for a long time. Eventually, we are very glad to be here in Baikonur to witness launch site operations of our new satellite. This is our second launch campaign in Baikonur after successful launch of Turksat 4A satellite in last year. All design, manufacturing and testing activities of the satellite have successfully completed in Japan Melco facilities. We have been working on this satellite project over the past 3 years to get reliable, high quality and enhanced performance product at the end in order to provide flawless services to our end customer. I would like to wish very successful launch and excellent in-orbit operations of the satellite on the upcoming days. Thank you to everybody once again who have contributed to our project for being a part of this success. Teşekkür ederim. Arigato gozaimasu. Spasiba.
Representing satellite manufacturer Melco for the Turksat 4B mission is Project Manager Ryuta Suzuki.
Hi, my name is Ryuta Suzuki. I'm the project manager for Turksat 4B spacecraft for Mitsubishi Electric. We have been very excited and thrilled to be back here in Baikonur, and we have been looking forward since the Turksat 4A campaign, which we had last year. Being here for the second time in Baikonur, we have been able to prepare ourselves better than last time. Thanks to this preparation and all the cooperation that we have received from ILS and Khrushchev, the campaign was very smooth. Taking this opportunity, I would like to thank our customer, Turksat, and their consultant, Telesat, for their understanding and cooperation throughout this project. And ILS and Khrushchev for their hard work, which enabled this launch. And I would also like to thank Mitsubishi Electric Turksat team and our management for their efforts and their dedication they put into this project, which made us possible to get here. Go Proton, go Turksat 4B. Thank you. Spasiba, teşekkür ederim, and arigatou gozaimasu.
As John indicated through communication with the Baikonur control room, we're now at the point in the mission where the BREEZEM upper stage is just getting started. A total of 5 burns are required before spacecraft separation. So John, can you give us an update on the mission right now?
Everything seems to be nominal as the orbital unit moves along the flight path as planned. I did get confirmation that the main engine start for the first of the 5 BREEZEM burns has occurred. Now, a few minutes from now, the BREEZEM will enter a planned blackout period, and this is when the vehicle is currently out of range of any of the designated Russian tracking stations, and we will not be scheduled to be back in communications again until after the second burn is complete, which is about an hour from now.
John, this is a question we often get about what happens after the Proton mission with respect to the satellite.
Well, while we just went away there, I did get confirmation that the first MECO has completed on schedule, so we're currently looking pretty good at the start of this launch. But to answer your question, after the spacecraft separation, Melco and Turksat will take over operation of the satellite from that point forward. Now, the spacecraft will then execute a series of planned operations over the next several days, which will include solar array deployment, reflector deployment, and a series of apogee engine burns. Now, those apogee engine burns will bring the orbit inclination down to 0 degrees and raise the perigee to match this apogee, which ultimately results in a circular geosynchronous orbit over the equator. After that, they'll follow a period of in-orbit testing, and the spacecraft will then settle into its operational slot of 50 degrees east longitude and begin to provide service to Turksat's customers.
All right, this concludes our live coverage of the launch of Turksat 4B satellite. Please check ilslaunch.com, the ILS Facebook and Twitter pages for regular updates on the mission. I want to thank John for co-hosting today's launch with me again. Thanks, John.
Thanks, Karen. It was great to co-host, as always, with you on this launch broadcast.
So on behalf of the ILS team and our partners and customers worldwide, I'm Karen Monahan, and thank you for watching.